Another banger. So welcome to another episode on differential calculus, and today we have continuity of a function. Now there are just three conditions, or we call it agioms, to satisfy to be satisfied when proving that the function is continuous. Now quick one: a function is continuous. A function is continuous is continuous at a point s equals to a if and only if these three agents are satisfied. Number one, f of a, that is the function at that value of a, is defined. What do you mean by when the function is defined? The function is defined when it has a value, like you put a inside this function and it gives you a number, not infinity. It gives you a number 0, 1, minus 2, any real number. It gives you a real number, then the function is satisfied. Sorry, the function is defined. F of a is defined. Then number two, the limit exists. That is, the limit as s tends to that at that point of f of x exists. So from the previous videos, I said a limit exists. The limit of a function exists for a piecewise function that has two sides. It exists when the left hand limit equals what? The right hand limit. So you have to put it there. So that means left hand limit minus f of x must be equal to what? The right hand limit of what? Of f of x. So that's it. So the limit, that means you have to prove that the left hand limit equals right hand limit. That's to show that the limit exists. Now the third one is that, now this one is the main condition. That is to confirm completely that this f of a you got here is the same thing as the limit you got here. That means f of a is equal to what? S tends to a of f of x. So if you can prove these three axioms, then the limit, then that means the function is continuous at the point s equals to what? At the point s equals to a. Now if any of these fail, then we say that the function is what? Is discontinuous. Now quickly, let's go straight into examples. Determine if the function is continuous at s equals to 2, and we have this piecewise function. Now you can see it here. Now it's very obvious this will be the left side of 2, shebi? Left hand limit of 2 as x tends to 2, that is x less than 2. Now where is right hand limit? Right hand limit is here. X, this is 2 less than x less than 7, meaning x is greater than 2. So that will be the right hand limit for x tends to 2. So the point here, the point target here is there, right? Oya, what's the first equation? We have to prove that f at 2 must be what? Must give you, must exist, right? So that's the first one. What's the first equation? F of a is defined, right? And what's that a here? The a here is what? 2. So that means f of 2. What's f of 2? Now checking the piecewise function here, f of 2, that is f of x at s equals to 2. Where is it? Can you see? X equals to 2. Can you see? What's the value here? Minus 3. So that means f of 2 is what? Minus 3. So it exists. It satisfies the first issue. Now the second one, real quick. Second one is that we have to show that the limit as x tends to that 2 of f of x exists too. How do we show? We have to find the left hand limit of 2, that is 2 minus, shebi? If you check your previous video, you find a revision like this of 2 minus. So what is the definition of that function at left hand side of 2? That's x less than 2, shebi? X less than 2. So what is the definition of the function? 1 minus x square. So that means this is the same thing as limit as x tends to what? 2 of what? 1 minus x square. Yeah, let's get the value. We have 1 minus, this is about 2 square. What's 1 minus 2 square? 2 squared is what? 4, right? So 1 minus 4 will give you what? Minus 3. I think he's trying to like correlate. Now let's find the left hand limit too. What's, sorry, the right hand limit? Now that's 2 plus of f of x. So yeah, check the definition of there. So this will be This will be this. Yes, we are correct here. So that means the right hand limit is what? 2x minus 7. The definition of that function for right hand limit, this x greater than 2, the same thing as x tends to what? 2 plus. Alright, so that will be what? Limit as x tends to 2, then 2x minus what? 7. So and that will be what? That will be limit. So put the value there. We have what? 2 into 2 minus 7, and that gives you what? Minus 3. Now the second condition is satisfied. It means the left hand limit is equal to what? The right hand limit, right? Isn't it? And which is what? Minus 3. So that means the limit is what's the limit? The limit is minus 3. Are we here now? So I can even write it this way, that is, since this one is equal to then the original limit is x tends to 2. X tends to 2 of f of x, which is what? Minus 3. Are we here now? So the third axiom, very simple. The third axiom, what will be the this thing? So it means comparing f of 2 and what? Limit as x tends to 2. If they are the same, thank God they are the same. F of 2 is minus 3. The limit as x tends to 2 is also what? Minus 3. So that means the function is continuous at the point x equals to 2. That's how to prove. Can you see? Very simple. So I'll just say f of a, which is f of 2, is equal to what? The limit as x tends to 2 of f of x, which is what? Minus 3. I'll now say, so therefore f of x is what? Is continuous. Mathematics is simple. Na you dey make am hard. F of x is continuous at what? X equals to 2. Shey na if you enjoy this video, please follow for more.